explainer. Before you can truly build anything powerful in Python, we really have to understand how the code runs under the hood. It's not just about memorizing syntax or staring at what the code looks like. It's about understanding the engine itself. Okay, let's dive into this. So, how does Python actually think? That's the golden question we're answering today. We're going to completely demystify Python's execution flow. And by the end of our time together, we aren't just going to look at isolated little concepts. No, we're actually going to trace a real-world financial data set line by line exactly the way the Python interpreter does. You'll get to see the logic happening in real time. Here's our quick roadmap for the explainer. It's a building blocks to capstone approach. We'll hit variables and data types, working with operators, directing control flow, mastering Python loops, and finally, the full execution trace. Starting with Section 1, variables and data types. Basically, the bricks of your program. Think of variables as exactly that, the fundamental bricks of your program. They are the absolute atomic units where all your information gets stored. But here's the cool part. Python handles these bricks uniquely, using something called dynamic typing. It automatically assigns data types based on the value, entirely without manual declaration. Seriously, if you've ever coded in C or Java, you absolutely know the pain of having to explicitly declare something like int revenue equals 50. Python completely removes that friction for us. Let's say revenue equals 50 and expenses equals 20. It's incredibly clean, right? Python automatically knows these are integers just by looking at the numbers. You assign it, and Python figures it out on the fly. It makes writing scripts just incredibly fast and fluid. But it gets even smarter. Watch what happens when we do some math. Let's say profit and revenue are both integers. The exact moment we divide them to calculate our margin, Python automatically converts that margin variable into a float, which is just a decimal number. It handles that conversion instantly, right behind the scenes, so your program doesn't crash from a random type mismatch. And hey, if you ever lose track of what type of data you're actually working with, the type function is your absolute best friend. It is a total lifesaver for constant debugging. Now, aside from integers and floats, Python has a few other core data types you're going to use daily. We've got bool for true or false values, str for text strings, and container types for holding multiple items together, things like lists, tuples, sets, and dicts. We'll actually be leaning heavily on lists as we move into our real-world examples in just a bit. Moving on to Section 2, working with operators, the tools of the trade. So, if variables are your bricks, operators are the tools you use to lay them and build something useful. You're probably already familiar with arithmetic operators like addition, subtraction, multiplication, and division. I mean, we just used division for our margin calculation. But I really want to draw your attention to comparison operators. Equals, not equals, greater than, less than. These don't just calculate a number. They return a Boolean value. True or false. And that single true or false response, that is the entire foundation for our next concept. Which brings us to Section 3, directing control flow, or making decisions. This is where your program stops being just a glorified calculator and starts actually making decisions. Control flow acts as a logic gate, and honestly, more importantly, it's a shield against bad data. Take a look at this financial snippet. We're checking if revenue is less than 0. If that condition is true, we print a warning and then we hit the continue keyword. In Python, continue immediately stops the current cycle. It skips the rest of the loop block and jumps right to the next piece of data. It ensures that if we have a negative revenue, which would obviously ruin our margin calculation, we just skip it entirely. And this brilliantly illustrates how Python can be both powerful and incredibly concise. Instead of writing out 4 lines of a clunky if-else block, you can compress that exact same logic into a one-line ternary operator. The syntax is incredibly clear. Margin equals profit divided by revenue. If revenue is greater than 0, else 0. I mean, it reads almost like plain English. It's absolutely perfect for keeping your code clean when the logic is simple. Okay, Section 4, mastering Python loops. Doing things repeatedly. Once you have the logic to handle a single piece of data, well, you need loops to iterate through massive data sets efficiently, right? Otherwise, you're writing the same code over and over. Now, you might know the basic for loop or looping with range to generate a sequence of numbers, but to write truly Pythonic code, you really want to use built-in functions that do the heavy lifting for you. Enumerate is fantastic because it gives you both the index counter and the value at the exact same time, so no more setting up manual counters. And zip is incredibly powerful. It lets you loop over 2 separate lists together, locking them into pairs perfectly. It just makes your code so much cleaner. Aside from for loops, we also have while loops. These simply keep running endlessly as long as a specific condition remains true. And to control these loops, you have three crucial keywords. We already saw continue. Then there's break, which doesn't just skip a cycle, it forces an exit from the loop completely. And finally, pass, which, well, literally does nothing at all. It's just a blank placeholder you can leave in your code when Python expects a block to be there, but maybe you haven't written the logic yet.
Finally, Section 5, the full execution trace, putting it all together. So the crucial point is, how does this all work together in the wild? Let's deliberately slow down here.
Let's act as the Python interpreter ourselves and trace the first three valid quarters of our financial data set line by line. Step 1, the loop grabs Q1. Step 2, it hits our control flow and checks if revenue is less than 0. For Q1, revenue is 50, so that comparison returns false. Because it's false, Python simply skips the warning block. Step 3, it safely calculates the margin and prints it. Step 4, Python hits the bottom of the block and loops right back to the top to grab Q2 and then Q3. It repeats the smooth, predictable cycle perfectly for all the valid data. But here is the climax of our code's execution. Watch the steps carefully. Step 1, Python grabs Q4, where somebody accidentally entered a revenue of -10. Yikes. Step 2, it checks if revenue is less than 0, and this time, it evaluates to true. Step 3, Python immediately enters the if block, prints our warning to the console, and then it hits that continue keyword. Step 4, instead of proceeding down to the margin calculation, which would have given us completely corrupted financial metrics, the continue command forces Python to jump straight back to the top of the loop. It successfully shields and protects the whole program from failing. And really, that is the beauty of execution flow. Python generally runs top to bottom, sure, but with conditionals and loops, you can dynamically branch, repeat, and skip logic based entirely on the data it encounters. Which leaves us with one final provocative thought for today. If variables, loops, and logic are just the raw building blocks, how do we structure hundreds or thousands of them into clean, complex, and reusable machines? Well, that's where object-oriented programming comes in, and that is exactly where you should take your learning next.